Okay, so I'll go over the three types of quadratics in this video. So different setup just right off the bat. I'm gonna do it online, or like I'm gonna do it in this format. From now on, it'll be easier and I'll be able to post more videos faster. Anyways, that's not why you're here. So there's three types of quadratics. There's just the regular ones. There's difference of squares and perfect squares. So the first one, let's just go through an example so we know exactly how to solve these kinds of problems with or without the formulas. So let's go ahead and start with x squared minus 3x plus 2. Now, the first thing that you'd want to do with this is you'd probably want to, if you want to find the two factors of this, you'd want to start with your x, and you'd multiply this factor and this factor to get your top value, so 2x squared, and this value is your bottom, so negative 3x. Now, your goal is to figure out what multiplies to get 2x squared, but adds to get negative 3x. You guys have done this on multiple tests. I don't think you guys have trouble with this. So for this, your factors would be negative 2x and negative x, or negative 1x, if that helps you visualize it better. So after you finish that, you would want to do your box, and you put this value and this value in these in opposite boxes, so negative 2x and negative 1x, and then you take this value and this value and put those in the other two boxes, so x squared and 2. So to get this to get the bottom left box, you would do x times x, and then this one would be negative 2, because negative 2 times x gives you negative 2x, and then it's a similar thing over here with negative 1. So your two factors for this would end up being x minus 2 times x minus 1. So that's basically the way you solve factors and things like that. And this is like a foolproof way of doing it. It'll come out correct each time. Other methods of solving these come in later in the chapter, but for now, I'm just going to focus on factoring quadratics in different ways. So now we have, let's just make a little barrier. Now we have difference of squares. So what this means is it's the opposite of perfect square. So if it's a perfect square, it's the same term multiplied by itself, like the same term multiplied by itself. So for difference of squares, it's the opposite of that. So you could see it as x squared minus 9. Before I get into the formula, let's just solve this one really quick. So you have your negative 9 x squared on top, and you have 0x, because there's no middle term in between these. So what multiplies to get negative 9x squared but adds to get 0? Well, negative 3x and 3x cancel each other out. So when you go into here, I'm sorry about my dog crying in the background. She wants me to open the door. So you'd have x squared, negative 9 in each of those boxes, and you have negative 3x and 3x. This would give you x, negative 3, and positive 3. This would end up factored, would become x minus 3 times x plus 3. This is difference of squares. And the formula for that is, so if you have the same term with just a sign change into the middle, so if you have x plus a times x minus a, this will end up being a squared minus b squared. Since you're using x's, this a would actually be x squared because in terms of this problem. But let's say you had your variable was like c or d. That's basically just what this placeholder means, is that first number squared. So that's difference of squares. And then there's also a perfect square. So let's do an example for that one. Let's say you have x squared minus 8x plus, plus 16. You do your x, 16x squared, negative 8x, negative 4x, and negative 4x. You do your box one more time, negative 4x, x squared, and 16. You get x, negative 4, negative 4. And then you get x minus 4 times x minus 4. This is the same term twice, and so you could just turn it into squares. So this is the exact same thing as x minus 4 squared. Because when something's squared, it just means that is whatever is in these parentheses is multiplied 2 times. So a lot of people, just one mistake with this a lot of people make is squaring each term. So you say, oh, if it's this, then that would be x, this would be x squared minus 16. But you can't do that because this actually means this. So that's why you have to use the box to solve something like this. So just be careful when you're doing squares and things like that. So this is a perfect square. And then the formula for this is, I'll just use x again because that's what we used in all of our problems. So x plus or minus a squared is the same as x squared plus minus 2xa plus a squared. The plus minus might seem a little funky just because you guys haven't really used it yet, I don't think. But basically that means is like either a plus b or a minus b. So in this case, we had a minus, so it was x squared minus 8x. So these two are going to match up. So if this is a minus used, then this is also going to be a minus, if that makes sense. So if this is a plus, if it's x plus a, then you're going to have x squared plus 2xa plus a squared. So I'll show you an example for the plus one really quick. If you had the exact same problem, and you can like try this and like do it on your own and see like how these two compare. If you had x squared plus 8x plus 16, that factor would be x plus 4 squared. So same thing, just you change the sign. And basically this one, the perfect square formula is you take your first number and that's squared, and then you multiply your second number by the first, you multiply the first and second number by 2. And this might seem like, oh, like that's kind of arbitrary, where did that even come from? You can see it in like when you do the box. So when you do this, it basically means the same thing. So when you had this box and you had this box, that's 2 of the same box. So you're basically just doubling whatever that box is, if that makes sense. You can compare it, you'll get the same type of answer anyways. So those are the 3 quadratics. This one doesn't have a name, it's just regular. And then you're going to have like non-factorable ones later, but you don't have to worry about that yet. So if you can factor it, these are the 3 different types of factors that you'd get. So also side note, this is done with the lesson, but on the Google Doc, I'm gonna put I can save these as PDFs. So I did it's not swiping. Oh my gosh. Okay. I have PDFs of I have a PDF of this, and then I'll put this one as a PDF too if you just want to look at that plain. So this is like just a review notes sheet, and then I did it with SOHCAHTOA too. So some of the PDFs that I'm going to link are not going to, like, might not have a video. They're just like reference sheets. Like, I think this explains enough about SOHCAHTOA to like learn it. So just for reference, not all the PDFs that I link will be videos as well. That's it for this. This is just basically on quadratics again.